worry about your naming. All right, we stop at naming of your alkane. So for the exercise 5.11, I won't discuss everything, but I'm particularly very interested in your question 4. Okay, because in your question 4 over there, I will be able to test both of the drawing and the naming. So sometimes lately the trend of the question is going to be something like this, where they give you the name, okay, and they ask you why the name is wrong. So you need to know both of the correct name. You need to know the correct name, and you need to know also at the same time why the name given over here is wrong. So kena ada reason, okay? But what I'm trying to show you over here, the reason tak payah susah. Okay, reason adalah apa yang kita belajar, itulah reason dia. So how do we start off by this question is we always start off with the drawing. Always mula dengan lukisan. Heptane. Heptane. How many carbon is heptane? Ifan? Ifan? Anissa?
Tujuh.
Alright, heptane is a 7 carbon. Thank you. So what do we start off with? I will start off with the 7 carbon straight chain. 7 carbon tak payah buat apa, just straight chain. And then I'll give the number 1, 2, 3 all the way to 7. Letak nombor siap-siap. Okay, letak nombor siap-siap. Jangan cari nama betul dulu. Kita letak lukisan dulu, ikut apa yang dia bagi. Walaupun nama dia salah. So dia dah bagi tahu 2,2-dimethyl. So dekat carbon nombor 2 saya ada CH3, dekat carbon nombor 2 saya ada CH3. Letak dulu. Okay? Nombor 6 ada ethyl. Carbon nombor 6 ada CH2, CH3. Just letak sahaja dulu. Okay? And then lengkapkan dengan hydrogen. So make sure every carbon can only have 4 bonds. Make sure you can count 1, 2, 3, 4 very nicely and very correctly. Letak bilangan hydrogen yang betul. And then only you proceed. Bila kamu lukis, kamu akan lukis ikut apa yang dia bagi walaupun salah. Okay? So over here, what is the wrong with the name given above? Anybody? Anyone? Apa yang salah dengan nama yang dia bagi?
Ethyl dengan methyl. Ethyl come first.
Ethyl come first. Okay, kawan kamu kata sebab ethyl come first, E datang dulu. So according to your friend, dia kata 6 ethyl and then 2,2-dimethyl heptane. Betul ke? Yang kata E come first tu? Okay, ada yang mengangguk. Alright, anybody else? Option 1. Anybody else? Semua setuju dengan yang tu? Hanya alphabetically order salah? Ada jawapan lain?
Start dengan 7. C yang ke-7.
Start dengan nombor 7. So kita akan kira dari yang nombor 7. So another one, Umi kata kita tak kira daripada kiri, kita kira daripada sini. Supaya ethyl dapat nombor terendah. 1, 2, 3, 4, 5, 6, 7. So kat sini akan dapat 2, kat sini akan dapat 6, 6. Betul? Okay. Option kedua. Lagi? Umi, lukis balik tak?
Lukis.
Okay, lukis balik. Okay, tak apa. Apa yang Umi cakap semua betul, tapi it's not the most correct thing that I want. What is the most correct thing? What is the biggest problem?
Carbon panjang.
Yes, is everybody agree that the heptane is the longest carbon? Alright. The very first thing that I will check, apa yang Umi check tu tak salah. You know, we are giving you all this, especially the alphabetically order, we are giving all this as a trick. Bila kamu baca soalan, oh, Miss Wong salah ni, E kena datang dulu. So ramai yang akan bagi jawapan 6 ethyl, yang macam Umi cakap lah. Ataupun ramai yang akan hanya lukis balik dan diorang akan assume heptane adalah longest carbon. Tak. So, macam mana nak jawab soalan macam ni? exactly back to the basic naming. There's two rules only. The first rule, longest carbon chain. The second rule, the lowest possible number. Betul? So back to the first rules adalah the longest carbon chain. The longest carbon chain over here is not 7. The longest carbon chain over here is 8. Setuju? Alright. Rantai terpanjang kat sini bukan 7. Rantai terpanjang kalau kamu tengok, kita akan jadikan ethyl sebagai bukan sebagai substituent. Dia akan duduk sebagai parent. That will be your 1, 2, 3, 4, 5, 6, 7, 8. Kamu akan ada 8 carbon sebagai parent. Nampak? Okay. Alif, start kira dari kiri atau kanan?
Kiri.
Kita akan start dari kira dari kiri. 1, 2, 3, 4, 5, 6, 7, 8. Kita akan start kira daripada kiri sebab carbon nombor 2 dah jumpa substituent. Kalau kita kira dari kanan, carbon nombor 3 baru jumpa substituent. Okay? Macam biasa, bulatkan substituent kamu terlebih dahulu. You want to give the correct name. So, kamu akan bulatkan substituent kamu terlebih dahulu. That is my methyl. That is my methyl. Dan kita dah ada nombor. So, kita boleh letak position teruslah. 6. Over here is a 2-methyl. Over here is also a 2-methyl. Alright. And guys, 3 benda yang sama. What prefixes do we use?
Try.
Try. And how do we arrange the number? Increasing order, ascending order. Okay. So 2, 2, 6 trimethyl octane. This is the correct name. Setuju? Okay. Dan Umi bagi jawapan tadi pasal alphabetically order, pasal lowest possible number. Semua tu tak salah. Tapi yang paling betul ataupun yang saya katakan macam ni lah. Priority paling tinggi adalah parent. Okay. Priority paling tinggi adalah parent. So, satu je explanation yang saya nak. Parent chain. Alright. Kamu just bagi tahu. Because the longest parent chain is not 7. It's not 7 carbon. But 8 carbon. Octane. Itu sahaja. Biasanya reason kita akan bagi satu je. Normally for this type of question, the reason that we need is only one. And which reason are we going to take? The reason which is the highest priority. Alright? Remember the naming rules and regulation that I give you the step? So the first step is your longest parent. Lepas tu baru lowest possible number. Lepas tu baru alphabetically order. Betul? So, satu je reason yang saya nak. And the only reason that I want is always the highest priority. Okay? Makes sense? Alright. So, this type of question is among the question that you will come out lah. So, we try another one over here. I have my 2-isopropyl 1,4-methyl heptane. Again, heptane 7 carbon. So, as always, just a kind reminder like I told you before the holiday. The most important thing is not only giving the name. The most important thing is to be able to draw your name correctly. That is the most important thing. And you know, the moment I see my substituent as 1-methyl heptane, I know the name is wrong. Betul? Satu tak boleh pegang methyl. Satu tak boleh pegang apa-apa carbon sebagai substituent sebab dia akan jadi rantai terpanjang. 1,4-methyl. 2-isopropyl. Isopropyl, I hope you remember, CH. Kita letak the echo ikan sikit supaya kamu nampak. That is my isopropyl, if you remember. Okay. And then you have your H2 over here because one is a branch already. So you have your H2, that is my H. That is my H2, that is my H. And the rest adalah H2, H3. So kat sini, longest carbon berapa? Longest carbon berapa?
8.
8. Okay, soalan saya. Alif kata 8 dengan siapa kata 8? Tak nampak tadi. Alif, 8 karbon kamu, berapa substituent?
1, 2, 3.
3. Alif punya 8 ada 3. So, I have 8 carbon, saya ada 2 pilihan. 8 carbon yang sangat straightforward is this one, my blue color. Okay, that is my first. Another 8 carbon that I can have is this. Nampak? Agree? Dua-dua adalah 8 carbon. Tak percaya, kira lah. So, my question, yang biru atau yang purple? When we have two longest carbon chain, which one do we choose?
Purple.
Purple. Kenapa purple?
Sebab dia ramai substituents.
Sebab dia ramai kawan, dia lagi ramai substituent. Kalau warna purple, saya ada 1 substituent, saya ada 2 substituent, saya ada 3 substituent. Betul? Alright. So, kalau warna purple, kita ada 3 substituent. Tapi kalau saya ambil warna biru, kalau kita ambil warna biru, apa yang tak duduk dalam warna biru? Yang tak duduk dalam warna biru adalah 1, 2. Betul? So, as we all agree, kalau rantai karbon yang sama panjang, the longest carbon chain yang sama panjang, we will be always taking the one that have more friends. Okay, we will always take the one that have more friends. 1, 2, 3. This is my 8 carbon. Alright, that is my longest carbon, 8 carbon. Next question. Alia, kira dari bawah atau kira dari kanan?
Bawah.
Bawah sebab?
Jumpa metal tu boleh letak dekat the lowest number.
Jumpa kawan dulu, jumpa substituent awal lagi. Okay, so we will have the substituent first. Therefore, we will start counting from here. 1, 2, 3, 4, 5, 6, 7, 8. Betul? Okay. So, kita akan ada 8. Therefore, we then move on to your substituent. I have my first substituent, second substituent, and the third substituent. As always, kita bagi nama terus kepada substituent. I have 2 methyl. I have 5 methyl as my substituent. Last but not least, I have 3 ethyl. Okay? Alright, ingat? Okay. So, kat sini kita boleh gabung. The methyl kita boleh gabung jadi 2,5-dimethyl. My next question. Bila saya nak jadikan dia nama betul, the correct name, the correct full name, which come first? Ethyl come first or dimethyl come first?
Ethyl.
Ethyl. Bukan D come first ke? Kenapa bukan D come first?
Sebab dia prefixes.
Sebab dia prefixes. Kita ambil kira tak D tu? Tak, kita ambil kira M. Ingat? Alright, jangan lupa. So, we will take count of the M. Prefixes will be ignored. Therefore, E come first. That's why the complete name will be 3-ethyl. E come first. And then 2,5-dimethyl. And your parent will be your octane over here. So, what do you think your reason will be? Adakah kita akan cerita pasal lowest possible number ataupun alphabetically order yang saya tanya tadi? Umi kata tak, Lim kata tak. So, we will be back to the parent. The parent is the one that changing from heptane to octane. So, your explanation will be still the parent, but extra one word for the parents is, we have 2 longest carbon chain. Kita ada 2 cara untuk dapat 8 carbon. Remember that? So, this explanation require one more word with the most substituent. Sama macam ayat tadi, the longest carbon chain is not 7. Parent chain pun saya terima, carbon chain pun saya terima. Alright, longest parent chain boleh, longest carbon chain boleh. It's not 7, but 8 carbon. So what I will normally do, I will normally 8 carbon, I will normally put down the parent name, octet, with the most substituent. Alright, bila masa kita kena ada with the most substituent ayat ni, when do we need this? When you know in your question, you have 2 longest carbon chain. Okay, so when you have 2 longest carbon chain, why do you choose this one? Because you have most substituent. Nampak? Okay, so one of the reason kenapa soalan macam ni akan keluar adalah obviously, well, you need to know everything, then only you can answer. You need to be able to draw, you need to be able to name, you need to be able to understand, then only kamu boleh jawab soalan ni. Okay, question? No? Alright. So, boleh buat? Ada masalah? Perlu saya bincang yang lain? Okay. Alright. And it just very quickly, alang-alang dah ada. So, kita just very quickly go through that. That is my pentane. 1, 2, 3, 4, ethyl. 5. Mana logik duduk kat sini? CH3H. So, this should be my drawing. Okay. And according to this drawing, it's quite obvious that my longest carbon chain is 6. 1, 2, 3, 4, 5, 6. 6 carbon with 2 substituent. 1, 2, 3, 4, 5, 6. 6 carbon with 1 substituent. So obviously this one lah. Betul. 6 carbon with 2 substituent. Another one yang boleh ada 6 carbon is this one. If you realize. Do you realize? Okay. Tapi kita akan ambil yang kuning. Kita tak ambil yang hijau. Kita ambil yang kuning sebab yang kuning ada 2 substituent. Remember that? Okay. So, the same reason. Kita akan letak nombor dulu. 1, 2, 3, 4, 5, 6. 6 carbon, therefore is a hexane. And then you have substituent over here. 1 substituent, 2 substituent. Simple, straightforward, 2 methyl, and then over here 3 ethyl, macam biasa. Combine according to the alphabetically order 3 ethyl, 2 methyl hexane. And the explanation, anybody? Anyone? The reason?
Because the longest parent chain is not 5 carbon but 6 carbon.
And?
With the most substituent.
With the most substituent. Thank you, Umi. Kena ada ayat with the most substituent sebab kita ada 2 rantai yang boleh pegang 6 carbon. Okay? And we will choose the one with most substituent. Yes. Any problem dengan naming? Alright. Like I said, like I promised, kita akan jumpa lagi naming hopefully this week sekali lagi untuk alkene. And believe it or not, naming will only get easier. Okay, naming will only get easier. Okay, so moving out from your naming, kita nak masuk physical property sikit dan cepat sahaja, tak ada apa. You need to write. I will give you the key point. I will give you the example that we will explain. Okay, but for physical property, every chapter akan ada physical property. Okay, every chapter ada physical property. So we are going to learn this again and again. So make sure you know how to explain, how to write. Physical property for alkane, we will learn for 2, boiling point, solubility. Kita akan ada 2, boiling point, solubility. Okay, talking about boiling point first. Your boiling point will have factor affecting. Kita ada 2 faktor yang akan mempengaruhi boiling point. And look at the way that I put. This is the priority. This is the second priority. I give you the number. Kadang-kadang saya akan bagi nombor, kadang-kadang saya tak bagi nombor. Kalau saya bagi nombor, bermakna benda tu ada priority. Kalau saya tak bagi nombor, bermakna benda tu tak ada priority. Okay? Ada priority. Bila saya bagi nombor, apa maksud dia? Sayang, bila ada priority means you must check this first. Kamu kena check benda ni terlebih dahulu. You need to check the molar mass first. If the molar mass is the same, Alright, if the molar mass is the same or similar, then only we check the molecular shape. Itu maksud saya. Faham? Okay. So, in the other words, if the boiling point or everybody boiling point increase lah, kita pergi kepada yang positif. If the boiling point increase means the molecular mass is higher. Alright, molecular mass higher having another name, which means more carbon atom. Saya rasa sangat jelas kalau saya ada C5H12 dengan saya ada C8H18. Which one have higher molar mass? C8. Betul? So, what I mean by the higher molecular mass also mean by the more carbon atom. Higher carbon atom, higher boiling point. Itu conclusion itu tak habis lagi. Itu baru conclusion. Next, if I want the boiling point to be higher, that means my molecular shape must be larger. Increase, okay, must be larger. Or in here, I have a very important keyword. Contact surface area. Alright, the keyword for your molecular shape adalah contact surface area. Okay. So contact surface area also need to be larger when you want to have a higher boiling point. So we are going to look at the example, don't worry. Okay, one by one. Molecular mass over here. So, first thing, bila saya ada soalan molecular mass, what are we going to look at? Saya guna contoh tutorial. Alright, saya guna contoh tutorial. In the tutorial question, one of the question adalah ethane, butane, pentane. Okay, so kita guna soalan tutorial. Soalan bagi ethane, butane, pentane, and they ask you to compare the boiling point. Okay, so how do we compare? Senang je. First thing yang kamu check, number of carbon. Ethane, carbon 2. Butane, carbon 4. Pentane, carbon 5. Betul? Alright, saya tak check pun hydrogen. Kenapa saya tak check hydrogen? Because hydrogen is only 1 gram per mole. But carbon is 12 gram per mole. So, bila carbon berbeza, straight away, molecular mass dia berbeza. Okay? So, if I want to arrange, let's say I want to have increasing boiling point. Okay, increasing boiling point. Ada dua cara nak arrange. Tengok betul-betul mana cara yang kamu nak guna. Obviously, the one that will have highest boiling point is your pentane. Your ethane will have the lowest. So, kalau soalan nak increasing means kita nak daripada rendah kepada tinggi. Betul? So, daripada rendah kepada tinggi ada dua cara nak susun. Satu adalah guna simbol, this one. Alright. Satu adalah kamu guna simbol lebih kecil atau lebih besar. This is one of the option. Second option, I'm not really a big fan of this. I'm not a big fan of this because budak selalu buat salah. Kamu selalu terbalik simbol ni. So, what I prefer is we will always use this method. Guna arrow, letak increasing boiling point, salin balik soalan. Salin balik soalan, guna increasing boiling point. And then kamu susun ethane. Kamu tahu kamu nak yang rendah sebab nak increasing. Increasing means yang rendah kepada yang tinggi. Ni saya akan contoh. Daripada yang rendah. So, rendah saya ethane, tak perlu guna simbol, tapi boleh guna comma. Alright. So, kalau kamu nak guna comma, if you want to use comma over here, nak guna comma, boleh. Dengan satu syarat. Benda ni kena ada. Faham? Alright. Okay. Dah? Guys, I want to remind you one thing. Teknik menjawab. If you use comma without any label, I don't know whether you know or not, but comma represent equal. Okay? Bila dalam susunan, comma sebenarnya melambangkan sama dengan. So, kita tak boleh guna comma tanpa label. And the label that I meant over here is this. Okay? I personally prefer, saya sebagai budak, saya sebagai pensyarah, saya personally prefer cara ni. Bukan sebab apa? Sebab kamu memang pening dengan yang ni. Aku tak tahu kenapa tapi memang hampa pening dengan yang ni. Alright, saya boleh guna. Dua-dua cara saya terima, dua-dua cara betul. Tapi mana yang kamu nak guna, pilih satu. Okay, pilih satu je mana yang kamu nak guna. You'll realize I will always use this. You'll realize I always come across with this. And I will normally do this one. Because the question can be increasing, the question can be decreasing. Betul? So, katakan soalan sekarang adalah decreasing. So, when the question is decreasing, I will remind myself. How do I remind myself? Decrease means I will move from the higher to the lower. Okay? That is what I will do. Soalan macam ni akan keluar every single year. Kenapa saya kata dia akan keluar every single year? Remember I say, benda ni, physical property, boiling point, solubility, kita akan ada acidity and basicity. 3 benda ni. 4 benda, sorry. Boiling point, solubility, acidity, basicity. Okay. 4 physical property ni akan ada kat semua chapter, especially boiling point. Boiling point solubility kita akan ulang 10 kali dalam 8 minggu ni. Sebab dia akan duduk kat every single chapter. So bila soalan ni, bila topik ini akan duduk kat every single chapter, dia akan keluar. Cuma dia keluar, dia tak keluar kat alkene, dia keluar kat alkohol. Dia tak keluar kat alkohol, dia keluar kat carbonyl. Dia tak keluar kat carbonyl, dia keluar kat carboxylic acid. Dia akan keluar. Okay? And maka pertama kamu is the arrangement. This is your 1 mark. You know why? You get this arrangement wrong, semua markah kat bawah salah. Your arrangement is wrong, kita tak baca apa yang kamu explain kat bawah. That is the rules and regulation in marking. Bukan saya jahat, misuang tengok yang misuang malas nak baca. Saya baca pun kamu takkan dapat markah. That is the rules in the exam. You wrong at the first mark, you wrong at the arrangement, kamu takkan dapat markah kat bawah. Okay, please get the arrangement right. Is that clear? Okay, get the arrangement right. And then in the exam, most of the time that we will always come across in the exam adalah explain lah, soalan physical property memang explain lah, betul. And you know what happened is, you always never get full mark. Because you always memorize the notes, you never answer the question. Okay? Always answer the question. Guna, soalan guna ethane, butane, pentane. Guna nama ethane, butane, pentane. Faham? Okay? Use that thing. So right now, the first thing that I will always write is, I want to show that the molecular mass is different. So what I will do is, I will say, ethane has 2 carbon. Alright, atom. Alright, butane has 4 carbon atom. And pentane has 5 carbon atom. Saya tak expect English yang muat band 6. Saya expect benda tu betul, straightforward, simple sahaja. Okay? Next, before you want to say anything about the molecular mass or anything, bagi tahu dulu molecular mass tu beza. As simple as this. Alright? As simple as this. And I don't know whether you realize or not, saya tak mention pun hydrogen. Betul? Sebab saya tak nak, I want to minimize your calculation. I want to minimize your work. Okay? So, bagi tahu bilangan karbon dia berbeza. So, bila bagi tahu bilangan karbon berbeza, then only you go for the arrangement. Ethane has lowest molecular mass. Okay? Followed by siapa? Followed by butane, then pentane. Jangan guna perkataan and. Budak selalu suka cakap followed by butane and pentane. Saya tak suka guna perkataan and. And tu melambangkan dua-dua tu sama. So siapa yang lagi tinggi lepas tu? So guna perkataan then. Mass followed by butane then pentane. Bermakna ethane paling rendah, lepas tu butane, lepas tu pentane. Alright? A little bit of English over here. And then lepas tu, okay, when you have the higher, lowest molar mass already, then we go for, therefore, the van der Waals forces. Sorry, saya nak letak statement ni dulu. Saya nak statement dulu, sorry, $1 million statement. Van der Waals forces is directly proportional. Is proportional. Tak nak directly is proportional. Alright, van der Waals forces is proportional with molecular mass. Van der Waals forces is always affected by molar mass. So molar mass rendah, therefore, nak cerita yang tinggi ke nak cerita yang rendah? Nak cerita, you all prefer cerita yang tinggi ke you all prefer cerita yang rendah? We choose one and then we keep it until the end. Tinggi atau rendah?
Tinggi.
Tinggi. Dua orang cakap tinggi. Therefore, tinggi. Therefore, pentane, which has highest molecular mass, has strongest van der Waals forces. Okay. Sambung ke atas, ayat tempat tak cukup. One more, two more sentence only. Okay. Therefore, banyak kali therefore. More energy required to overcome the strong van der Waals forces in pentane. Thus, boiling point of pentane is highest. Okay. Habis lagi sebab kita ada 3 orang. Followed by butane dan ethane. Nampak? Salin dulu. Alright. Boleh? Okay. So, anyway, the most important thing, guys, is this one. This is the first mark that you should get. Because if you didn't get this one mark, we won't read for the rest of the thing. Okay? Jangan salin nota saya 100%. Boleh guna nota tu, boleh guna ayat dalam nota tu. Make sure kamu jawab soalan. That is always the problem. Okay? Saya tak boleh bagi the exact answer in the notes sebab jawab soalan kamu boleh berubah. Saya boleh bagi ethane, butane, pentane. Lepas tu saya boleh bagi ethane, propane, hexane. Betul? Soalan tu boleh berubah tapi konsep tu sama. Okay? So, bila masa yang kita akan ada, ni soalan, ni exam pula, ni nota punya ayat lah. Okay? Bila masa kita nak tengok molecular shape? Bila masa kita nak tengok molecular shape? Contoh saya bagi contoh yang senang sahaja. Saya semua adalah CH3, CH2, CH2, CH3. Okay, first one. Second one, I have my butane. Second one, I have my 2-methyl propane. CH3, CH, Saya nak letak bracket macam jahat je. Saya letak bracket hampa kembang sendiri. CH3. 2 methyl propane. And then I have my cyclobutane. Ni soalan. Okay. Sama. I want to arrange increasing boiling point. Boleh? Okay. So, what do we do if the question only give you the name? Soalan mungkin hanya boleh bagi nama. Soalan mungkin tak bagi semua ni. Soalan hanya mungkin bagi nama. So, what do you do when the question give you name? You draw it, obviously. Kamu akan lukis. Okay? When you draw it, you realize one little thing. Pakcik ni pegang 4 carbon, total. Pakcik ni pegang 4 carbon, total. Pakcik ni pegang 4 carbon, total. Realize that? So, bila semua pegang 4 carbon, you realize one thing. Okay? All of them has similar molecular mass. Setuju? So, bila similar molecular mass, kita tak boleh bincang dah. Kita tak boleh bincang faktor molecular mass tadi sebab semua sama berat. So, bila kita tak boleh bincang molecular mass, then you go for your molecular shape. Okay? That is what I mean by priority. So, first thing, you always check the number of carbon. Number of carbon sekarang tak sama. Then, kita akan bincang molecular mass terus. Kalau number of carbon sama, then baru kita bincang molecular shape. Molecular shape, there is 3 different conditions. One is straight chain. One is branches. Okay. Sorry, can I have cyclic first? Saya nak susun terus. Cyclic, straight chain, and branches. Okay. Contact surface area for cyclic is the largest compared to the straight chain compared to the branches. Contact surface area is the highest over here. Contact surface area is the lowest over here. Ingat yang ni. Okay. Bilangan karbon sama. Sayang, syarat satu bilangan karbon sama. Alright, bilangan karbon sama baru boleh bincang benda ni. So, cyclic, contact surface area paling tinggi, followed by straight chain, followed by branches. So, sekarang, bila contact surface area tinggi, apa yang berlaku? Stronger van der Waals forces, straight away. Okay, stronger van der Waals forces. Mestilah, betul. Kawasan yang ada untuk form bond atau form intermolecular forces is very large. So when the area is large, straight away the forces will be stronger. Okay, stronger over that. So, ingat yang ni, kita balik kepada soalan kita. Ada masalah dengan yang ni? Kita balik kepada soalan kita. Okay, so everybody agree with this? I have molecular shape, I have 3 different types. I have cyclic, I have straight chain, I have branches. So this is my question. Alright? And you have draw it. Soalan bagi nama. Kamu dah lukis. Okay, kamu dah lukis. So kamu pun gunalah. Kamu pun susunlah. Saya nak increasing boiling point. Increasing boiling point means saya nak daripada yang rendah. Daripada yang rendah kepada yang tinggi. So my question, siapa yang rendah di sini? Boiling point siapa yang paling rendah rasa-rasa?
Two methyl propane.
2 methyl propane adalah boiling point paling rendah, followed by
Butane.
Butane.
and then last but not least cyclobutane. Betul? Okay, nampak? So, how do we explain? First and foremost, kenapa kita bincang molecular shape? Kenapa faktor ni kita pilih? Because the similar molecular mass, betul? So, bagi tahu dulu, all compound above has 4 carbon atom. Okay. Similar molecular mass. Bagi tahu dulu yang ni. Because of the similar molecular mass, then only we discuss the molecular shape. Okay, then only we discuss the molecular shape. Dan kita bagi tahu setiap satu property dia, setiap satu molecular shape. Tadi you all kata nak bincang yang paling tinggi, so kita mula dengan yang paling tinggi. Cyclobutane is a cyclate which has the largest contact surface area. Kamu kata nak mula dengan yang tinggi. So, untuk semua soalan yang akan datang, kita akan mula dengan yang tinggi. Okay? Followed by butane, which is a straight chain. Then 2-methylpropane, which has a branch. Bagi tahu. Kalau ada 2 cabang, 2. Kalau ada 3, 3 lah. Depends pada soalan. Okay? Dah? Dan kita still bincang yang tinggi. Alright? Therefore, when the Wall forces, oh by the way, when the Wall forces, lupa nak bagi tahu. V besar, D kecil, W besar. Alright? Therefore, when the Wall forces is strongest in cyclobutane, okay, then in butane followed by 2-methylpropane. More energy required, ayat yang sama. Alright, ayat yang sebiji sahaja, more energy required to overcome the strong van der Waals forces in cyclobutane. Okay. So ayat last dia adalah, sambunglah ayat last dia sama. This boiling point of cyclobutane is highest. Okay, ayat sama, sambung. Okay. Boleh tulis. Sayang, boiling point akan keluar every single year. Keluar kat siapa dia? Dah? Boleh? So, balik kepada your physical properties. Balik kepada your boiling point over here. Your boiling point ada 2 faktor. Always remember, how do we use the factor? There is a priority 1 and 2. Therefore, molecular mass similar. If the molecular mass similar, then only you can discuss the molecular shape. Molecular shape ada 3. Your cyclate, your straight chain. Alright. And then last but not least, your branches. Okay. And cara yang paling senang, tak payah kira molar mass, tak payah kira apa, kita akan tengok pada number of carbon. Okay, tu adalah cara paling senang. Alright. Okay. Any problem with boiling point? Boleh Okay, solubility. Yes.
Are they going to mix the two factors in the same question? Like both
Are they
S
going to
and
mix the two factors in the same question? You can. We
so
will have
your
those questions later.
Okay.
All right, we will have those questions when we come across different chapter, when you can write this better, when you can write this easily, then you can come across a question that you need to discuss both factor. Okay, contoh soalan because Lim asked, so I can give you the example of the question. Let's say I have 4 carbon just now, my cyclic, and then that is my first structure, and then I have my butane. Okay, but at the same time, I can have my hexane. Okay, so in here, I have my A, I have my B, I have my C. Pakcik ni pegang 4 carbon, 6 carbon. Betul? Boiling point siapa paling tinggi?
C.
C. Sebab antara ni, this one is number 1. Because over here, between the compound C, between your compound C and your compound A and B, kita akan bincang apa? Kita akan bincang molecular mass. Okay? Yang ni nombor 1 sebab dia 6 carbon dia menang. Tapi 2 ni sekarang pegang 4 carbon. Therefore, what will happen is, you will have 2 things over here. The number 2 will be this. The number 3 will be this. And the factor that you will discuss for these 2 will be your molecular shape. Okay, boleh. Yes, of course, they can ask 2 factors together. Okay, we will come across the question like that. Okay. Boleh. Thank you. All right. Again, sayang, when we have 2 things and I told you the priority. So priority means pakcik ni mesti kena nombor 1, bilangan carbon lebih. Van der Waals forces straight away will be stronger. Walaupun dia hanya straight chain, dia bukan cyclic. Clear? Okay. Van der Waals forces is extremely highly affected by your molar mass. Okay. All right. Moving to your solubility over here. Moving to your solubility. Okay, solubility, normally, the solubility that we learn is in water. Okay, most of the time. So, over here, nothing much to talk about. Kita akan tengok hydrophobic area dengan hydrophilic area lebih banyak lepas ni. Okay, lepas ni. Cuma kat sini, solubility for alkane. Alkane is always insoluble in water. Betul? Agree? And favorite question. So I prepare you a favorite answer. Anything. Kali pertama saya bagi tahu So lepas ni saya tanya kenapa tak soluble dalam air, kamu kena bagi tahu kenapa kat saya. Anything that insoluble in water. Anything that I say insoluble in water is only one reason. Because it cannot form hydrogen bond with water molecule. It cannot form hydrogen bond with water molecule. Apa-apa yang saya kata insoluble lepas ni. Alright, kalau kita jumpa apa-apa yang saya kata insoluble in water, the reason is only one. Because it cannot form hydrogen bond with water molecule. That's why dia takkan larut. Okay? Boleh. So always remember, your alkane over here will always be insoluble in water no matter how many carbon. 1 carbon all the way up to 10 carbon, dia takkan larut dalam air. Is only one reason because none of them can form hydrogen bond with water molecule. So diorang semua tak larut dalam air. Faham? Okay. Question? Solubility, nothing much. Solubility, I think solubility will start to have a lot when we talk about alcohol. I think alcohol, yes. All right. Before alcohol, I think most of them adalah tak larut. Okay. The very boring first hour. I know, but you know, physical property will come out every year, so I still need to teach. So next, kita nak masuk reaction. So this one we will have more fun doing it because you need to do. I mean, you really need to do. Then it will be fun lah. Chemical reaction in alkane is very simple. All right, chemical reaction in alkane is very simple. You only have 2 types, your combustion and your halogenation. Combustion, nothing much. We have two types of combustion. Can I know what type of combustion is that? Anyone?
Complete. Complete and incomplete.
Complete dengan incomplete. Nabila kata complete dengan incomplete. What makes complete and incomplete different?
Yang complete is it means complete senang kata excess of oxygen, and incomplete kurang oksigen, so produk dia pun akan berbeza.
Produk dia berbeza. Laila, produk dia berbeza. Nabila kata produk dia berbeza. Apa yang berbeza di antara complete dengan incomplete dari segi produk? Laila?
Carbon dioxide dengan carbon monoxide.
Yes. Alright, I don't want to spend so long on your combustion. Combustion ada dua jenis. Your complete and your incomplete, you learn both of them in your school. So complete combustion adalah when you have excess of oxygen and it will give rise to your carbon dioxide gas, water and also your heat, obviously. Okay. So saya just bagi contoh yang sangat senang. C4. Kenapa suka sangat C4 hari ni? Tak nak C5, C4 je. Saya yang pun ingat Miss Wan tak aktif benda lain pula C4 je. Okay. C5H12. So when I have my C5H12 liquids, I burn in my oxygen gas. So my product over here will be carbon dioxide gas and also water. What I'm trying to show you only how to balance. How do we balance it? Tengok pada bilangan carbon. Carbon adalah 5, so carbon dioxide 5. Hydrogen adalah 12. 12 bahagi 2, so water adalah 6. Okay. So 5H2O over there will need 5 water. Sorry, 5 carbon dioxide over there will need 10 oxygen. Betul? Okay. And water set. Over here, I need 10 oxygen. And then over here, I need 6 oxygen. So total, I need 16 oxygen. So 8 H2O. Betul? Tak ada apa, nak ajar balance equation sahaja. Just very quickly, the only things that make it different from your school, make sure you know the phase. Alright, make sure you know the phase. And a kind reminder, bila kita ada hydrocarbon, C1 until C4 adalah gas. Betul? Okay, C5 and above, kita akan ada liquid. Alright, make sure you know that. So incomplete combustion, what makes it different? Limited oxygen, alkane produce carbon monoxide and water. So if I'm having the C5, exactly the same C5, H12, liquid, I will have my oxygen gas, but the things that will change is carbon monoxide and also your water. Okay, yang ni akan berubah lah. Carbon monoxide tetap akan dapat 5, yang ni tetap akan dapat 6. But the number of oxygen that you need will change from 16 just now until 11 only over here. Okay? So 11 over here, 6. So I have 11 oxygen, 11 boleh letak, what do we call, pecahan. Okay, 11 over 2. Tak ada masalah. Question? Okay, everybody should know and everybody should be able to differentiate that. Yang kita nak focus is this one. Okay? Halogenation of alkane. First and foremost, alkane, if you remember, alkane is your saturated hydrocarbon. Okay? If you remember what is meant by saturated hydrocarbon means only single bond. Dia tak ada double bond. Betul? That is your alkane. Betul? Dia tak ada carbon-carbon double bond. Semua alkane kamu adalah C berapa carbon pun saya tak kisah, tapi semua adalah single bond like this. So bila semua adalah single bond, you cannot do any more addition. Kita tak boleh ada pertambahan dah. Kenapa tak boleh ada pertambahan? Sebab semua dah tepuk, dah saturated. Okay, semua dah sangat tepuk. Everything is already saturated. Dah tak ada ikatan yang free. So what can we do? We can only do substitution. Okay? And what type of substitution we are having? What type of substitution we are having? If we are only doing halogenation, halogenation having two types, bromine, okay, bromination, atau chlorination. Perasan atau tak, yang ni adalah homolytic cleavage. Betul? Sebab apa dia homolytic cleavage? Sebab carbon dengan hydrogen pun adalah homolytic cleavage. Okay? Remember the word homolytic cleavage previously? Okay? Can I ask one thing? Homolytic cleavage, what is the product produced as an intermediate? What is the product that will produce as an intermediate? Br positive, Br minus? Alif? Ikatan putus. Alright, homolytic cleavage. Ikatan putus. Sama rata. So, apa yang akan terhasil?
Free radical.
Free radical.
Free radical. Akan hasilkan free radical. That's why the type of reaction is free radical. Okay. By the way, a bit of teknik menjawab soalan, bukan teknik menjawab, baca soalan betul-betul. Ni adalah type of reaction. Tengok ni adalah type of reaction. Betul? What is halogenation kalau macam tu, Miss Wong? Bila masa nak jawab halogenation, bila masa nak jawab free radical substitution. Halogenation kalau soalan tanya name the reaction. The reaction is halogenation. The type of reaction is free radical substitution. Nampak? Okay. And in the free radical substitution, we need one little thing. We need UV. Okay. So what is the function of UV? We definitely need UV. UV is to provide energy for the homolytic cleavage to form free radical. Okay. Can I ask you one thing? Kalau homolytic cleavage, what type of arrow we are using?
Half-headed.
Half-headed. Ingat yang tu, kita akan tengok arrow hari ni. Kita akan masuk mekanisme. Saya nak habiskan alkane hari ni. Saya nak habiskan alkane hari ni supaya kamu boleh buat tutorial dan ada soalan apa-apa kamu boleh tanya on Wednesday. Okay, kita nak habiskan alkane hari ni. So, this one. Halogenation ada dua. Monobromination. Monochlorination. Okay. Apa maksud mono? Mono means we only substitute satu. Satu je. Kita akan ganti satu je. So for the monobromination, what are we using? We are using Br2. Okay. Br2 UV. Chlorination, kita akan guna Cl2 UV. Okay. Kadang-kadang kamu akan nampak soalan akan tulis Br2 in CH2Cl2 UV. Okay, kadang-kadang dia akan ada benda tu. In CH2Cl2 UV. Okay, ladies and gentlemen, for the first time I'm telling you and also the last time, ingat benda ni. CH2Cl2, CH2Cl2 adalah inert solvent. Diorang adalah inert solvent. Do you know what is inert solvent? Diorang adalah pelarut yang diorang takkan buat apa-apa. Okay? Dia adalah inert solvent. Dia duduk sana tak buat apa-apa. Dia tak terlibat langsung dalam reaction. Yang akan terlibat dalam reaction is your Br2 UV and also your Cl2 UV. Is that clear? Jangan tertipu dengan CH2Cl2. CH2Cl2 is an inert solvent. Okay? Alright, boleh Kalau boleh, kita nak masuk soalan dan saya nak masuk, saya mula dengan soalan susah. Kita mula dengan soalan senang. Okay. How should a reaction look like? What are we going to do? I start off with a very simple question. Okay. As simple as CH3, CH3. Okay. So CH3, CH3 kalau teacher kembangkan, dia akan jadi like this. Okay. So So if I have a CH3 react with a Br2 in inert solvent under UV. Remember monobromination? Okay. Monobromination means kita akan ganti. Remember, kita buat substitution. So what is actually happening over here is kita akan ada pacik ni. Okay. Kita akan ambil pacik ni, react dengan Br dan salah satu hidrogen. Kenapa saya kata salah satu hidrogen? Do you realize both of the carbon is the same? Okay. Same as in dua-dua adalah primary. Setuju? Dan setuju tak kalau Miss Wong ganti mana-mana 6 hidrogen ini, mana-mana satu daripada 6 hidrogen ni, structure kamu akan tetap sama. Tak percaya, saya tunjuk yang ni. I substitute one of the H with Br. Okay, I substitute one of the H with Br. And you will have a byproduct. Jangan lupa byproduct kamu. Okay, HBr. Okay, I use the word byproduct. You will heard this a lot. What is actually byproduct? Byproduct adalah produk sampingan yang kita dapat. It's not the product. It's not the main product that we want. Okay, byproduct. Okay. Alright. First and foremost, good news is kita tak perlu balance equation in organic. You only need to have all the reactant, all the product that kamu tak perlu balance. Okay. And do you agree that this will be the same? Can you take a quick look? Setuju tak kalau Miss Wong ganti Br kat sini sama je? Nampak tak dia orang sama? Nampak So perlu tak tunjuk produk yang kedua? Tak perlulah. Betul? Tak perlulah. So tak payahlah. Kita ada satu produk je lah. Betul? Kita ada satu produk je. So what happen if I have another structure? Dah? Can we move on a little? Okay. For this question, we have 3 carbon. Okay. And do you realize that I have my primary, secondary? Okay. So is all the hydrogen the same? No. Okay. Class of carbon adalah satu guidance. Class of carbon is only a guidance for you to identify whether the hydrogen is the same or not. Sometimes the same class of carbon will also give you different compound. Okay, so we will have 2 product over here. The first product I think you will agree is saya ganti Br duduk pada carbon pertama. Okay, saya ganti Br duduk carbon pertama. Bila saya ganti Br duduk carbon pertama, you realize that my hydrogen daripada 3 jadi 2. Betul? Dia bukan tambah kita ganti salah satu hydrogen dengan tu. Kalau untuk siapa yang tak nampak, kamu boleh kembangkan. Untuk siapa yang tak nampak, it's okay untuk kamu kembangkan. Tak ada masalah. Alright? Carbon ni adalah carbon yang saya nak tengok. Saya tak kembang, saya tak nampak lah Miss Wong. Okay, kembangkan. Tak ada masalah. Okay, expand only that particular carbon. As always, saya tak suka kamu kembang semua benda. Sebab bila kamu kembang semua benda, kamu pening. Okay, dah. Next. Perlu tak ganti hidrogen kedua? Akan berbeza atau akan sama? If I replace anything on the secondary carbon over here, let's say. Berbeza kan? Alright, and do you realize that when I am talking about that particular carbon and that particular hydrogen, orang lain akan kekal dan tak berubah. CH3 kekal, okay? CH kekal. The only things that change adalah hydrogen yang kita tengah bincang tadi. And pacik ni kekal. Realize that? You only need to focus on the things that is changing. Kalau benda tu tak berubah, kita akan kekalkan dia. Tak berubah. Nampak tak? Benda yang kekal remain unchanged. Benda yang kekal remain unchanged. So kita kisah ke dia berapa carbon? Kita salin balik je weh. Nampak? Kita salin balik je. So, do I need to substitute anything next to it? Do I need to substitute anything on the third carbon? Perlu ganti? Nabila kata tak. Kenapa Nabila?
Sebab dua-dua BR dah substitute.
Sebab dua-dua BR. Tak, saya tak kata equation ni balance. Alright? Saya tak kata equation ni perlu balance. Saya ada banyak BR lagi weh. Perlu tak ganti lagi yang ketiga? Umi say no. Anis? No. Kalau tak confident, untuk siapa yang tak confident, saya tunjuk. Kalau saya ganti carbon ketiga, saya akan dapat benda ni. Betul? Perlu tak? Perlu tak?
Tak.
Kenapa tak perlu Liv?
Sebab dia sama yang mula-mula tu.
Sebab dia akan sama dengan yang first one. Betul? So tak payah lah. Sebab sama. And are we done over here? Are we done? No. Lim, what is missing?
The byproduct HBr.
The byproduct HBr. Nampak? Okay. Boleh? Alright. Nampak And ladies and gentlemen, untuk bromination, you will have a condition called major and minor product. Alright, you will have a major product and a minor product. Okay, major product can be up to 99%. Your minor product can be less than 1%. And this will only happen to bromination. And how do I identify major product and minor product? Senang. Remember the class of carbon that we learned? Okay. How do I identify the major minor? Look at the BR located at which carbon. The BR for the first carbon is primary. The BR for the second product is a secondary. Betul? Okay. Primary, secondary. So, siapa jadi major? Kelas lagi tinggi akan jadi major. Secondary and primary, secondary lebih tinggi. That's why this will be the major product. Okay. Biasanya kita tak payah label minor. Biasanya kita hanya label major. Kita tak perlu label kat minor tu, tak salah. Kalau kamu nak label minor tak salah. Tapi yang penting label minor. Label major. Okay. So kenapa dia major? Sebab kelas. Kelas lagi tinggi means lebih stabil. Alright, kelas lagi tinggi bermakna lebih stabil. That's why it's a major product. Okay. Boleh? Question so far? Question so far? Tak ada? Soalan tenang je kan? Okay. We go for chlorination a little. Okay, for chlorination. And tadi kita dah guna cyclic, atau tadi kita dah guna straight chain. So sekarang saya nak guna cyclic untuk chlorination. Let's say I have cyclopropane. So cyclopropane, as you all know, it looks something like this. Okay. And as we all know, every carbon must have 4 bonds. So in fact, diorang semua sebenarnya dah penuh dengan hydrogen. Agree on that? Okay. So using chlorination means I have my cyclopropane react with Cl2. Same thing under inert solvent with the presence of UV. And soalan saya, perlu tak kita ganti semua hydrogen? Dan ada beza tak kalau kita ganti mana-mana hydrogen? No. Okay. And let's say saya nak ganti hydrogen. Biasanya saya akan kembangkan pada carbon yang saya nak ganti je. Saya akan kembangkan pada carbon yang saya nak ganti je. Biasanya lah. Alright. Saya tak akan kembangkan semua. And the byproduct, what do you think the byproduct will be in this case? HCl. Yes, thank you. Betul? Okay, ni soalan senang lah, tak ada apa. What about a methyl cyclopropane? We will have quite a few products over here. Okay, I will have a Cl2, CH2Cl2, UV. Dah? Okay. Don't forget untuk kembangkan. And tadi kita ada satu produk je. Kenapa tadi ada satu produk je? Sebab semua adalah secondary and semua secondary itu sama. Kat sini, saya ada primary, saya ada tertiary, saya ada secondary. Setuju? Okay, nampak dah sikit? Alright, nampak dah sikit? So, can we start with the primary? So, the primary is CH3. So, what I will do is we are going to replace, we are going to substitute one of the hydrogen in the CH3. Carbon, salah satu hydrogen ganti dengan Cl, pakcik ni still pegang H2 lah. Dan perasan tak benda yang tak berubah kat ring tu kekal? Betul tak? Cyclic tu kekal, tak ada apa yang berubah. Agree? Okay. Next. Kita ada tertiary. So, tertiary ni pun ada hydrogen. Tertiary ini pun ada hydrogen. So, apa yang kita boleh buat? Kita boleh ganti hydrogen tu lah. Dan bila kita nak ganti hydrogen tu, CH3 kekal. Alright, CH3 kekal. Hydrogen ni je kita ganti. Setuju? Ada soalan tanya tak? Alright. Alkane hanya ada satu reaction. Alkane only have one reaction and alkane will come out in the exam as a 7 or 8 mark question. Dia nak keluar apa lagi kalau dia tak keluar chlorination atau bromination? Dia mesti keluar. Okay? So please get it. And then next, you have another product. Do you realize that you have another product? Tadi Laila ke siapa saya tak ingat. Tapi dia akan kata, budak akan selalu kata, teacher, mana boleh ada 3 produk? Cl2 ada 2 je. Weh, Cl2 tu saya letak satu titik. Bila if I drop a drop of Cl2, bukan ada 2 biji je Cl weh. Dalam tu ada millions of Cl, okay? Alright, we never do balancing equation in organic. Okay? In organic, what we will do is, apa yang saya ada, apa resipi saya, apa yang saya guna, what is the condition, what is the reactant, and apa yang saya dapat, apa jadi byproduct dia. Tu je, kita tak pernah balance equation. Okay? So, the next one that we are going to have is the secondary carbon. So, we all know that the secondary carbon over here having 2 hydrogen each. Sama, kalau saya hanya nak ganti hydrogen di carbon tersebut, yang lain semua kekal. Pakcik ni ganti dengan Cl, kekal lagi dengan satu H. Setuju? Soalan saya, do I need to ganti H ini? Tak payah. Sebab sama je. Sebab kamu akan perasan dia akan jadi sama je nanti. Kat sini, jarak ni sama je. Betul? Alright. Kalau tak percayalah. Salah satu cara nak tahu dia sama ke tak, kita bagi nama. Pakcik ni akan jadi 1 chloro, 2 methyl, cyclopropane. Kalau saya ganti di bawah, okay, do you realize that it will also be 1 chloro, 2 methyl cyclopropane? It's the same, isn't it? Nampak sama? Okay. And byproduct HCl. Okay. Any questions so far? Any questions so far? Okay, are we still together? Good, good. Okay. Next. Tadi bromination ada major minor. chlorination, no major minor. Yes, no major minor. All products are equals. Okay. All products are equal. Bermakna kalau saya ada 3 produk kat sini, 3 ni akan jadi 33%, 33% and 33%. Semua adalah sama. Dalam chlorination, dia tak boleh ada major minor. Okay, wait, 33% ni saya yang label kat kamu. Hang jangan label dalam exam weh. Bila dia tak ada label major minor, kita tak perlu label lah major minor tu. Okay, 33.33% ni saya yang ajar ni, sekarang saya letak lah. Okay, dalam exam tak payah letak. Okay, dalam exam tak payah letak. Okay, so what makes bromination and chlorination different other than using Br and Cl2? Budak selalu akan nampak, oh, bromination guna Br2, chlorination guna Cl2. Sayang, banyak lagi. Monobromination adalah selective. Okay. Alright, selective. Apa maksud selective? Selective means there will be major, minor product. Dia akan memilih siapa yang dia nak. Dia akan memilih, oh, saya nak primary atau saya nak secondary. So, dia adalah dikatakan selective. Kenapa dia boleh memilih? Because it react slower. Bromine is less reactive. Okay? Bromine is less reactive. Bila bromine less reactive, dia akan react slower. Dia bergerak lambat. Bila dia bergerak lambat, dia boleh pilih. Okay? So, bila dia bergerak lambat, dia boleh pilih. Berbanding dengan chlorination, chlorine is unselective. Why chlorine is unselective? Unselective means no major minor. Alright? Why no major minor and why it will become unselective? Because your Cl2 is very reactive. Bila dia very reactive, dia akan bergerak cepat. Dia akan bergerak sangat cepat. Dia tak akan pilih sebab saya nak cepat je kerja saya. So I won't choose. Saya tak kisah hang primary ke secondary, tertiary, saya ambil je. Alright? So when you become unselective, you will have no major minor because you never choose. But when Br is less reactive over here, when your Br is less reactive over here, you will then tend to choose. Kamu akan bergerak lambat. So bila kamu bergerak lambat, kamu boleh pilih. Dan sayang, bila kita pilih, kita mesti pilih kelas yang tinggi lah. Betul? Kalau ada primary dengan secondary, saya definitely pilih secondary. Saya ada primary dengan tertiary, saya definitely pilih tertiary. Nampak? Okay. So that is what we mean by the bromination and the chlorination. Bromination, there will be major minor product because in the monobromination, bromine is less reactive. Therefore, it will react very slow and that's why it can be selective. Vice versa, chlorination is very reactive, that's why it react very fast. Bila dia bergerak laju, it will become very unselective. Dia tak akan pilih, dia ambil je apa yang kosong tu. Primary ke secondary, tertiary, dia akan ambil je. That's why there is only bromination question, kamu boleh label major. Faham? Chlorination tak boleh label major. Setakat ni, ada soalan? Tak ada? Kita buat soalan tutur sikit. Ni saya tak tahu soalan mana, tapi soalan tutur kamu. Okay, ni soalan tutur kamu. Saya ambil, ada 4 kot saya ambil. Okay, a few. So over here, bila dia cyclic, I want to remind you again, semua masih adalah duduk di bawah free radical substitution. Semua masih duduk di bawah free radical substitution. Okay, so bila dia free radical substitution, kamu kena make sure kamu nampak carbon tersebut masih pegang hydrogen. And for this question, how many product you have? 1, 2, 3, 4. How many product do you think you have?
One.
One. There will be only one product. You can ganti mana-mana yang kamu minat. Tak suka ganti atas, misalnya saya suka ganti yang ni. Gantilah mana yang kamu minat. Biasanya saya hanya akan kembangkan carbon yang saya nak ganti sahaja. As always, we will only focus on the carbon that we want to do the reaction. Okay? Only one product, Mr. Lim, this is not a product. This is a byproduct. Okay? We don't count that as a product. So kalau soalan tanya product, this is the only answer. HCl hanya untuk melengkapkan equation. Okay? All right. Next, over here, how many product do you think we have?
Dua.
Dua. Ganti kat carbon mana? 1, 2, 3, 4.
Carbon 2 dengan 3.
2 dengan 3. Alif kata ganti kat 2 dan 3 untuk dapat 2 produk. Anybody else?
1 dengan 2.
1 dengan 2. 1 dengan 2. Ganti 1 akan sama dengan gantikan?
4.
Ganti 1 akan sama dengan gantikan 4. Okay. Ganti 2 akan sama dengan gantikan 3. Betul? Nampak ke sayang? Nampak dah So, your product, one of the product adalah CH2, CH2Cl ganti kat 4. Satu lagi produk adalah ganti kat 3 boleh, ganti kat 2 boleh. Sama sahaja. Okay. And my question, ada major minor?
No.
No. Kenapa no?
Sebab ada klorin.
Sebab dia klorin. Okay, dia klorin, dia bergerak cepat, dia unselective. Betul? Senang. Okay, very easy. Next, over here. Expand the structure a little. Expand the structure and tell me how many product you have. Ada berapa?
2.
2. Satu what class? Another one what class?
1 primary, satu lagi tertiary.
Satu primary, satu lagi tertiary. Yang ni adalah primary kita. Ganti mana-mana kat primary ni akan sama dan yang ni adalah tertiary saya. Very good. So, CH3, CH3. Tertiary saya adalah yang pertama saya akan letak. And then saya ganti mana-mana dekat my primary. Okay. H kekal. CH3 katakanlah saya ganti yang ni. Setuju? Ada yang tak nampak ke? Byproduct HBr. So, I have my tertiary, I have my primary. Ada major minor?
Ada
Siapa major?
tertiary.
Siapa major Ifan? Tertiary. Pakcik ni major. We normally label major only. We seldom label both. Of course, if you want to label this major minor, tak salah. Okay, tapi biasanya markah kita akan bagi kat major je. Okay? Alright. Next. How many product do you think? Cuba buat yang ni. Saya nak jawapan. Hantar kat WhatsApp. Okay, how about this? Bermula soalan ni semua soalan tutor ni. Soalan tutor pun saya ada bagi banyak reaction, betul? Okay, try all the question in the tutorial and for all the bromination, as long as the bromination, make sure kamu label major. Okay, soalan tanya ke soalan tak tanya saya tak kisah, tapi kalau the bromination, make sure kamu label major. Okay, I don't want to waste the time. So go and try all your tutorial, make sure you understand how many products that you have. Okay. Over here, saya nak masuk mechanism. The last thing for your alkane. Okay. And untuk SES, this is the benda yang samalah kita udah ulang kan. Okay. So, whenever it's mechanism, you need to show the bond breaking. Okay. What is about the mechanism is you need to show the bond breaking and the bond forming. And in the free radical substitution, it's a homolytic cleavage, as we all agree just now. So when it's a homolytic cleavage, there is only one thing, half-headed arrow. Remember? Okay. Oh, sorry. Half-headed arrow. Okay. So we'll be using this a lot. And can anybody tell me, all right, manusia SES tersebut, how many steps do we have in free radical substitution?
3.
3.
Kita ada 3 steps. Step 1, step 2, step 3. Can anybody tell me what is step 1?
Chain initiation.
Chain initiation. Okay. Step 2, Alif.
Tak ingat, bisa ingat step 3.
Ada step 3 hang ingat tu je. Lagi? Siapa lagi?
Propagation.
Chain propagation. Alright, propagation. Step ketiga.
Chain elimination.
Chain elimination.
Termination.
Aku eliminate hang adalah chain termination. Okay. So for your free radical substitution, step 1, step 2, step 3 ada 3 steps. Step 1 is chain initiation, chain propagation, chain termination. So like the name said, bila dia adalah initiation, this is where the reaction started. Okay, that is how we initiate the reaction. Propagation is how we expand the reaction, how we propagate the reaction, how we make it bigger, how we make sure everyone reacted. Chain termination is how do we stop the reaction. Why do we need to stop the reaction? Because the free radical that you produce, we know that we are going to produce free radical with it. The free radical that we produce is extremely reactive. Okay, sangat-sangat reactive. That's why you need to have a chain termination to ensure that the reaction stop at certain point. Okay, so kita akan guna reaction yang sangat senang. Saya guna butane kepada 2-bromobutane. Okay, so first and foremost, draw the butane as always. The 2-bromobutane shall look something like this. Okay. So, step 1. Step 1 adalah chain initiation. Step 1 adalah step yang paling senang. And the chain initiation over here will involve BR. Chain initiation will definitely involve what do we use. Kalau kita guna BR lah. Kalau kita guna CL lah. Sayang, I am expecting everybody to draw this together. Because next week when you see me face to face for the first time, next week, the very first thing that you do is mechanism on the board. Okay, so make sure you get it. So, half-headed arrow, we need to show the bond that is break. So the bond that is break is between BR. This is what going to happen. Half-headed arrow daripada ikatan ke BR. Half-headed arrow daripada ikatan ke BR. Okay, so what are you going to produce? You are going to produce your BR free radical plus BR free radical. Okay. Next, that is your first step. That's it. Itu sahaja, tak ada apa dah. So your second step adalah your step 2. Where your step 2 is your chain propagation. We are going to propagate the reaction. We are going to make the reaction even bigger, even wider. Semua orang kena reacted. So what are we going to use in the chain propagation adalah kita akan ambil the butane. Okay. Kita akan ambil the butane yang tak react dengan apa-apa lagi. And we are going to expand only one bond. We are only going to expand the bond that we are going to use. Okay. You know what? I nak make sure I have enough space. So let's make our step 1, step 2 in new slide. Yeah. So You're going to take your butane and we only expand the bond that we need. We only expand this bond. Kenapa kita only expand this bond? Because I already know this is the one that will be substituted. Yang ni yang saya nak tunjuk. So hanya tunjuk ikatan tu. Jangan expand semua benda. Sebab bila kamu expand semua benda tu lah yang kamu akan jadi pening sebenarnya. Okay? So half-headed bond from the bond to the carbon. Half-headed. Nampak ya? Half-headed. From the bond to the hydrogen, half-headed. Okay? Dia akan react dengan apa? Dia akan react dengan the free radical that you obtain from step 1. Alright? Dengar dulu sebelum kamu salin. I'll give you time. You need to know how the electron move. Then only you know. So, we are going to take the butane that is not reacted. Why we are going to take the butane is not reacted? Because in the step 1, only Br2, only Br free radical has been formed. So the Br free radical yang terhasil kat step 1 akan pergi kacau apa? Dia akan pergi kacau butane yang tak buat apa lagi. Alright, so you take the free radical that you produce in your step 1, you go and propagate the reaction to butane. So what happened next is, to be honest, the bond that break first, or I would say what will happen in the reaction first is not the bond break between carbon and hydrogen. The things that happen is actually the Br akan pergi kacau the hydrogen. Okay, the Br akan pergi kacau hydrogen. Jumpa half-headed arrow. Kenapa hydrogen? Sebab Br pergi kacau hydrogen, sebab tu hydrogen nak elektron dia balik. Dan bila hydrogen nak elektron dia balik, sebab tu carbon pun okey lah, Han nak elektron Han balik, aku pun ambil balik elektron aku balik. Nampak? Okay. This is the first arrow that you should have. This is where it started because the Br is a free radical. So the Br free radical akan pergi kacau hydrogen yang dia nak kacau tu. So dia pergi kacau hydrogen, hydrogen pun okey aku nak duduk dengan hang. So bila hydrogen nak duduk dengan dia, dia akan ambil balik elektron kat dia. So bila hydrogen ambil balik elektron, carbon pun ambil balik elektron. That's why I'll give you time to copy, just take a look first. That's why dia akan jadi CH3, CH. Alright, the bond that break akan hilang. But I hope you realize one thing. Benda yang tak berubah, kekal. Nampak? Benda yang tak berubah akan kekal. Plus, benda yang terhasil adalah HBr. And I will always show the bond that is break, show the bond that is formed. Nampak? Okay? Salin dulu yang ni. Kita tak habis lagi, salin dulu yang ni. Make sure all the arrow adalah betul. Make sure the arrow jumpa ya. Make sure the arrow jumpa. Because they are going to form a bond. So make sure the arrow berjumpa. Okay. Dah? Okay. Kalau dah, kita sambung. So, tengok dulu. Next, what happened is, we are going to take this, the new free radical that you form. See that? We form a new free radical. Kalau tadi saya ambil Br untuk kacau butane yang tak buat apa. So, sekarang saya ada butane. It's still under step 2 ya. Look at it. It's still under step 2. So, saya akan ambil butane yang dah jadi free radical. Okay, look at the free radical sitting on the carbon. Saya akan ambil butane yang dah jadi free radical. Saya akan kacau siapa pula? Saya akan kacau Br yang belum jadi free radical. Remember the word propagation? propagation means we want to spread the thing. So what are we going to do is we are going to take the free radical, kacau orang yang belum jadi free radical. Okay, so right now I have this free radical that we produced in the previous step 2. So I'll take it and I'll react with the Br yang belum jadi free radical. Nampak? So the same story. The story is still from the free radical, dia akan pergi kacau Br. So Br pun okay, Br akan tergugat lah. Br pun nak pergi duduk dengan dia. So bila Br nak pergi duduk kat dia, arrow, dia akan ambil balik elektron dulu. Dia kena bawa elektron dia pergi duduk dengan CH. Okay. Lepas tu, ikatan ada 2 elektron. Satu Br kiri ambil, satu lagi Br kanan ambil. Nampak? So what happen is, same thing. Benda yang tak berubah akan kekal. Benda ni tak berubah, kekal duduk dan diam. Benda yang tak berubah, kekal duduk dan diam. Benda yang akan berubah adalah, I form a new bond with Br. Betul? And then the Br2 broke and form a free radical. Agree? Okay, salin dulu. Salin betul-betul ya, termasuk arrow saya semua jelas ya. Arrow saya semua jelas. Okay. Faham ke setakat ni? I enjoy mechanism. I don't know whether you do or not, but I really enjoy mechanism. It makes everything much clearer. You know how the reaction actually happen. Okay? So jangan hafal sahaja. Make sure kamu faham. Okay? Kalau dah, can we take a quick look? Perasan tak kita hasilkan balik Br free radical? So, apa yang Br free radical yang terhasil ni akan buat? Br free radical yang terhasil ni akan buat, dia akan pergi kacau butane satu lagi. Perasan tak step ni akan berulang balik? Br free radical yang terhasil, dia akan pergi kacau pula butane yang ada lagi tu. Sebab dalam beaker kamu sayang, bila dalam beaker kamu, kita bukan ada Br2 satu je, kita ada Br2 millions of them. Betul? Alright, dan bukan semua yang dah jadi free radical. Ada setengah yang dah jadi free radical, ada yang belum. Sama juga dengan butane. Ada butane yang masih butane, ada butane yang dah jadi free radical. Betul? Okay, so dia akan pergi kacau. Br yang dah jadi free radical ini, yang kamu baru hasilkan Br free radical ini, akan pergi kacau pula butane yang lain. So step atas akan berulang. Nampak? Alright, step atas akan berulang. Betul? Tapi bila step atas berulang, kita tak payah tunjuk lah because it will be the same thing. Step atas akan berulang, hasilkan pula benda ni, step bawah pula berulang. Nampak? So dia akan berulang sehingga semua orang dah jadi free radical dalam beaker kamu. Bila semua orang dah jadi free radical, everybody in here tak jadi dah Br2. Semua dah jadi free radical, semua dah jadi produk, betul? Semua dah jadi free radical, jadi produk. Okay? What happened next? You move on to your termination. You cannot propagate already because everybody become free radical. Betul? So when everybody has become free radical, then it's time to stop. It's time to go for your chain termination. So in the chain termination, what will happen is you are going to combine all the possible free radical. Alright, free radical yang saya wujud sekarang adalah Br. Free radical yang saya wujud sekarang adalah butane. So you are going to combine all the possible free radical. So the very first possible adalah Br free radical combine balik dengan Br free radical. Okay, take a quick look at the detail look, not a quick look at the arrow. Tadi arrow pecah. Kalau daripada ikatan arrow pecah. Sekarang daripada free radical arrow masuk. Kenapa arrow masuk? Because new bond is going to form. Br, bonded balik. Nampak? Okay. Another possible, of course, is nak salin satu-satu ke nak saya explain semua lepas tu salin? Salin satu-satu? Yes, no? Okay, salin dulu dan sebab saya nampak kamu duduk salin dulu. Pay attention at the arrow. The arrow is moving from the dot to the center, from the dot to the center. Dia kena jumpa. Okay. Yeah. So the second possible, of course, is the butane itself. Butane dengan diri dia sendiri. Butane with another butane. Alright. Free radical jangan tinggal ya. Titik dot tu jangan tinggal. So sama cerita macam tadi sayang. Dia akan jumpa di tengah. Betul. Dia akan jumpa di tengah. Daripada dot, jumpa di tengah. Daripada dot, jumpa di tengah. And bila kamu salin, wait, tengok ni weh. Tak payah susun balik elok-elok. Tengok dulu. Saya tak nak kamu susun balik merapu-rapu. Teacher konon nak bagi elok. Tak payah. Ni terikat kan? Alright. Tak payah cantik weh. Susun macam ni je. Dah habis cerita. Nampak? Tak payah gigih. Teacher nak bagi panjang. Rantai paling panjang. 6 kabel lah nak. Tak payah. Saya tak nak nama, saya tak nak rantai paling panjang, saya tak nak lukisan elok pun. Saya nak ikatan tu betul antara carbon yang betul. Faham? That's it. So, saya tak nak kamu bazir masa susun balik. That's it. And you are done and you get the mark. Okay? Tolong jangan susun balik. Jangan gigih nak susun balik. Okay? Dah. Okay. Is there any other possible? Ada lagi? Saya kata all possible free radical. So BR dengan BR, butane dengan butane, lagi?
BR dengan butane.
BR dengan butane atau butane dengan BR samalah kan? So saya akan gabung pula my BR with my butane. Okay? All possible. All possible. Semua yang boleh wujud. So same thing. From the titik, jumpa di tengah from the titik. Half-headed arrow. Okay? Daripada titik, jumpa kat tengah half-headed arrow. So, cerita yang sama sayang, saya tak perlu kamu susun balik elok-elok macam-macam. You know, elok-elok kemal-kemal ke pelik-pelik semua tak payah. Saya nak betul je sayang. So ikatan tu saya nak betul sahaja. Okay. And like I always say, saya biasa akan tunjuk ikatan yang putus dan ikatan yang terhasil tu. Orang lain saya takkan kembang. Orang lain kita salin balik je. Alright. Kalau tepi tadi, tepi ni kiri kanan ni, kalau saya letak 10 carbon ke 20 carbon ke, does it make any difference? Do you realize that you only copy paste those that doesn't do anything? So this is chemistry. This is organic chemistry. Jangan tertipu dengan benda yang ada kat kiri kanan yang dia tak buat apa tu. Alright? Benda ni kamu salin balik je. Jangan tertipu dengan soalan kamu. We only focus on what we want to focus. Is that clear? Okay? So that is the 3 step. Okay, that is the 3 step. We go back for a bit. That is my step 1, my chain initiation. Just a kind reminder over here, in the step chain initiation, what will happen is we want to initiate the reaction. So how do we initiate the reaction? We break the BR. And as I say, the bond that we are going to break or the bond that we are going to form, I'm going to show it. Don't forget, it's a half-headed arrow sebab semua adalah homolytic cleavage. Remember we learned that? Okay, homolytic cleavage. Okay, next. You know, kalau dalam mechanism, kalau saya tak ada benda ni nama equation. Betul? Okay? Kalau saya tak ada arrow, benda ni nama equation. Mechanism, because you have this half-headed arrow. Agree? Therefore, yang akan dapat markah, ladies and gentlemen, yang akan dapat markah is this arrow. Dalam mekanisme yang akan dapat markah adalah this arrow. So, tolong lukis betul-betul. Okay? This is where your marks will be. That is your step 1. Step 1 is always to produce free radical. Okay? Step 1 is always to produce free radical. Step 2 adalah propagation. I don't know whether you realize one thing or not, but do you realize in the chain propagation, kita ada free radical, kita ada neutral. Kita ada free radical, kita ada neutral. Realize that? Kita ada free radical, nampak free radical? Kita ada neutral. Betul? Sama juga, kita ada neutral, kita ada free radical. Realize that? Dalam propagation, what are we doing is we want to expand our power. Kita nak membesar-besarkan keadaan tu. So your free radical will always disturb the neutral. Your free radical will always disturb the neutral. Faham? Dia takkan kacau free radical yang lain. Sebab apa? Sebab saya nak bagi influence saya kepada orang lain. So saya dah jadi free radical. Saya nak influence orang yang belum jadi free radical tu jadi free radical. That is what I'm going to do. So in the propagation, your mind, your concept is I want to make sure everybody become free radical. So when I am a free radical, I will be taking the free radical from step 1. This is the free radical from step 1. I will react with the neutral of my reactant. So kalau butane lah, kalau propane lah, betul? Apa-apalah, cyclo lah. Okay? And then saya akan hasilkan free radical benda tu. So free radical yang terhasil akan dibawa turun. Nampak tak? Okay? So this free radical will then react or influence the other neutral thing. Nampak? So dalam propagation, the one point that you can check your propagation betul atau tak, it will be forever neutral, free radical, neutral, free radical. Neutral, free radical, neutral, free radical. Dia kena adalah orang yang neutral dengan orang yang free radical. Orang yang neutral dengan orang yang free radical. See that? Okay. Termination, vice versa. Termination is actually the vice versa of your initiation. Chain initiation, we want to start the reaction. So I want to produce the free radical. From the chain termination, nama pun terminate with, your band 6, right, everybody? So we want to stop everything. And how do we stop everything? We combine all the free radical. See that? We combine all the free radical. So semua adalah free radical gabung dengan free radical dan your product semua adalah neutral. Nampak? Okay, that is a bit of tips for you on how you check your answer. Okay? Any question for this mechanism so far? No? Okay, and everybody's supposed to be copying this down, betul? So I will give you, do you have class after my class? Okay, there's 10 more minutes. I'll give you 10 minutes to upload this. Tak payah buat pun, sepatutnya kamu dah salin. To upload this thing on the Google Classroom. Okay, saya nak make sure kamu salin pun betul. Boleh? Do me one little favor. We are coming to the end of alkane already. That's it about alkane. Alright? Kalau boleh hari Rabu saya nak masuk naming alkene sikit. So, do me one favor. Do the exercise of alkane. Okay? The reaction 5.1.2. Do the reaction. Do the mechanism. Try the mechanism. Okay? Ada mechanism yang tak boleh buat lagi. Hari Rabu saya boleh tunjuk lagi. Hari Rabu saya akan tunjuk sekali lagi untuk cyclic. Tapi kalau kamu faham yang ni, cyclic kamu boleh buat. My tips adalah always show the bond that is going to break. That is my tips. You need to show the bond that is involved. Okay? So try to do the mechanism again and try all the exercise in your tutorial. And on Wednesday, I'll see you again. Hopefully, we can go into alkene naming a little. Okay, boleh? Soalan, question, and welcome back to KMPP. Alright. Ada soalan? Tak ada soalan? Okay, I'll give you a place in Google Classroom and I want this mechanism. Alright? Kalau tak ada apa, I think that's it for today.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Thank you.
Thank you.